So our first speaker is going to be Dr. Brett Denevi giving an update with a sort of a moon focus. Brett, take it away.
All right, thank you, Sam. Hi, everyone. I was asked to speak today on behalf of the panel on Mercury and the Moon about lunar science in the Planetary Science and Astrobiology Decadal Survey report that was released last month. So next slide, please. I served as the vice chair for that panel and was on the steering group. So in the process of this decadal survey, each of the panels gave input to the steering group. And it was the steering group that was ultimately responsible for the recommendations that I will discuss today. But this was truly a huge community effort, and I want to acknowledge the panelists who gave so much of their time and worked so earnestly on behalf of the community, as well as all of the white paper authors, the mission concept study participants, the presenters at open meetings, and truly all of the lunar science community for getting us to this really exciting and critical point in lunar science, where we are just on the cusp of an incredible decade to come. Next slide, please. So the science opportunities afforded by the moon are really infused throughout the science chapters of the Decadal Survey. You have likely heard that this decadal survey was organized around science themes and questions related to those themes. And I hope that as you dig into these questions, you see how the investigations that we can undertake at the moon really are critical to making fundamental advances in planetary science and astrobiology in this decade. Next slide, please. I've pulled a couple of examples of how these science questions are organized, such as in question 3, which is broadly about the origin of Earth and inner solar system bodies. There is lunar science scattered throughout this question, but also there are specific sub-questions about how the Earth-Moon system formed and how we can learn about the moon forming impact. And then at the bottom here, there are examples of strategic research activities for how these questions can be addressed, such as with new remote or in situ measurements, sample return, or by developing model predictions. Next slide, please. As another example, I want to note that you really should look through each of these chapters, even the ones with titles about atmospheres or life, where science of the moon might seem to be a less obvious contributor, but is nonetheless an important contributor, such as how the early bombardment of the Earth-Moon system, as recorded on the moon, can help us to understand Earth's early environment and how this environment shaped the emergence and the evolution of life. Next slide, please. And then some of the themes that emerged from all of these questions and strategic research activities are summarized in the programmatic chapter in a box that I just included here to call your attention to it, that lays out the overarching themes for lunar science that were prioritized by the committee. The first one is to uncover the record of solar system origin and early history preserved in the composition, structure, and ancient surface of the moon. The second, to understand the geologic processes that shaped the early Earth that are best preserved on the moon, including volcanism, magmatism, tectonism, impacts. And third, to reveal inner solar system volatile origin and delivery processes. Next slide, please. So, recognizing the fundamental advances in planetary science and astrobiology that can be made at the moon, and consistent with long-standing priorities for lunar science, the committee prioritized a mission concept that would enable an in situ investigation of diverse terrains throughout the South Pole Aitken Basin. You can see an example traverse here. And the collection and caching of key samples that address these important science themes. So there's a lot going on at the moon, and the committee recognized that the Discovery, CLIPS, and Simplex programs can provide opportunities to address focused science objectives at the moon, but also that the broader science goals that have for decades been a priority require more ambitious missions. Next slide. Thus, the Endurance A mission was prioritized as a medium-class strategic mission. And this includes a rover, which is directly based on the Intrepid rover PMCS study. It would be delivered to the moon by a CLIPS lander. It would bring its cache of up to 100 kilograms of samples collected from diverse terrains within SPA to the Artemis base camp, and the Artemis astronauts would return those to Earth. And the committee felt that this coordination with Artemis provides an excellent opportunity for partnership, and that the result would truly be flagship level science at a fraction of the cost to PSD. Next slide, please. The important science contributions of a lunar geophysical network were also recognized in its inclusion on the list of mission themes that were prioritized for New Frontiers 6 and 7, as it was also for New Frontiers 5. And again, the broader science objectives of this mission to constrain geologic processes, bulk composition, the distribution of heat-producing elements, and the moon's interior state and thermal evolution require a New Frontiers class mission. Next slide, please. There's also strong support for the Commercial Lunar Payload Services program's goal of enabling reliable and affordable access to the lunar surface. And the model of purchasing delivery services to the moon is a really promising approach that can benefit the Planetary Science Division and lunar science. The recommendation suggests that NASA should develop a plan to maximize the science return from CLIPS by, for example, allowing investigators to propose instrument suites coupled to specific landing sites. And we're glad to hear that that is being investigated now. And NASA should also evaluate future prospects for CLIPS within other mission programs. I know these could include Discovery or New Frontiers, as well as other destinations. Next slide. Finally, there was also an important recommendation about the Lunar Discovery and Exploration Program, LDEP. The committee worked to understand where within NASA lunar science and exploration is happening. And the org chart I'm showing here is the attempt to do that. It is showing just the SMD portion of that. And LDEP lies in kind of the middle right side there. It's funded through PSD, but managed by SEO. And LDEP funds many, but not all, lunar programs in PSD, but many of those are not currently managed by LDEP. You can see this is in contrast to MEP, the Mars Exploration Program, on the left side there, which is in which the responsibility, authority, and accountability for Mars science is aligned. Next slide, please. So in the current LDEP structure, no single organizational chain has authority for executing lunar science missions and accomplishing lunar science. And further, there is, as of yet, no overall strategy for lunar scientific exploration or a program or program director or chief lunar scientist to lead such a plan. So the recommendation from the survey was that the Planetary Science Division, which is responsible for accomplishing lunar science goals, as was mentioned earlier this morning, should execute a strategic program to accomplish planetary science objectives at the moon with an organizational structure that follows the best management practices of NASA and aligns responsibility, authority, and accountability. And this program was felt to be merited because of the wide array of robotic, commercial, and human exploration going on, not just by the US, but internationally. And thus, real cooperation is needed to ensure that resources are optimized towards accomplishing our highest priority science objectives. Next slide, please. I will breeze through these last few slides here, but in the recommended program for the coming decade, there is support for programs that are critical to lunar science, and for a robust LDEP budget and a mid-decade start of Endurance A. Next slide, please. You can see in the budget sand chart with LDEP in the darkest blue there, kind of in the middle, at nearly $500 million per year throughout the decade. Next slide. Even in the level program, which is a reduced funding level from the recommended program, there is still the same level of support for LDEP and for a mid-decade start for Endurance A. And next slide. And so these are the so-called decision rules for the case where the funding is less than the level program. And you can see by the priority order here that there was strong committee support for LDEP and the science represented by the endurance concept, with, at the worst case, a delayed start for that mission until later in the decade. Next slide, please. So I will stop here, and as Dr. Lori Glaze said this morning, lunar science is planetary science, and I think there is tremendous excitement for what can be accomplished at the moon in the coming decade. Thank you, and happy to answer questions after we hear from Jen.